So Adam completed his PhD in neurophysiology and biomechanics at the University of Guelph in Canada in 2016 and helped co-found the Esports Science Research Lab alongside Dr. Mark Campbell, which is based in Lero at the University of Limerick. This was the first of its kind in Europe at the time. So Adam's research interests include everything about how the brain processes sensory information to improve health and performance, with much of his work currently extended to the study of gaming and esports performance. So I'll hand over to Adam now to give his talk entitled, Can Brain Stimulation Make You a Better Gamer? So off you go, Adam.
Perfect, thanks for that, Sean.
No problem.
So I'll just share my screen here and dive right in. And okay, hopefully everyone can see my screen there. So yeah, delighted to be here today. This is my first time doing a Pint of Science, so I did bring my pint. Unfortunately, it's not in real version this year. It's virtual, but delighted nonetheless. And my talk today stems around whether or not brain stimulation can make you a better gamer. Now, before we find the answer to that, I'd like to preface with an understanding about how the brain works as we acquire, perform any skill for that matter, just to give a little bit of a background. So when we're performing any skill, I'll just put my drink down here. When we're performing any skill, we rely on what's called our motor memory, or our memory about how to perform that skill successfully. And that initiates in the kind of frontal lobe part of the brain generally. And what we do with that is we generate what's called a motor program. And the motor program is basically a series of action potentials or neural signals that go from one neuron to the other until they reach the motor cortex, which is the green part of the brain indicated there on the right. And that last port of call, that kind of action or motor cortex area, that's the part of the brain that has the neurons that send the signal to our muscles in order to move our limbs in the right way to perform an action successfully, be that throwing a ball in this case, or for gaming performance, which I'll allude to later. And just like anything, when we perform a skill, we often will make mistakes at the skill. We'll perform the skill successfully. Sometimes there's different motor programs that, based on how good our memory is of that skill or how to perform that skill, we can pick different motor programs. And you can think of that cascade of neurons kind of like the kind of the combos that you would use in a video game. I'm sure many of you have played Nintendo or N64 or any of those old video games. I'm showing my age a little bit, but putting in the right combo of buttons to kind of create the action that you want to perform, the same sort of thing happens in the brain. Now, that's all well and good, and the action goes down to the muscles to produce action, but we need to figure out how successful that action was. And that's where this sensory feedback element comes in. So we have our different sensory systems such as sight and touch, and we also have sensors in our muscles that kind of tell us about how our limbs are moving. All that information comes back to the brain and gets processed and basically gets compared to kind of that motor program or that motor memory. And we basically determine whether or not the action was successful. We can either see that the ball was in the hoop or not in this example, and we can kind of adjust the next motor program for the next time we do that action. And then obviously, yes, that updates kind of our motor plan or our motor memory here. So just to give two examples of this. So if we talk about with practice, in the case of shooting this ball and it being a miss, so an unsuccessful, we picked the wrong motor program, we produced an action and it didn't produce a successful outcome as we intended. And we had a certain pattern of neurons that fired there. So the sensory feedback and the motor memory that we thought was going to work, they didn't agree. So that tells the brain that what we chose and what we did wasn't successful. So what we'll do is we'll downgrade that motor program. We'll try something else. And let's say we make one. So we pick the motor program that was successful. Sensory feedback combines and gets compared with kind of that memory, and it updates the motor program. And the idea is that the more and more that we practice, and we practice efficiently and effectively, the more that we strengthen the connections the connect motor program. So we strengthen the connections of the correct pathway, and we kind of devalue the connections of the incorrect pathway. And that's basically the process that happens through practice and iteration as we become an expert in any skill. And it kind of all stems back to this kind of old adage, what fires together wires together. So the idea is that the neurons that continuously fire together, the ones that are associated with the correct action with proper practice, they will start to wire together, and you'll be more likely to recruit that pattern of neurons or that motor program. Now, where does brain stimulation affect this kind of loop or this process? So what we're doing with brain stimulation is we're actually passing a really small electrical current to the brain, and we're affecting the neurons at the endpoint. So we're in the motor cortex, in that action area there. We're basically making those neurons more easily able to be activated. So when the correct motor program goes down here in the yellow arrow, hopefully everyone can see my mouse here. The idea that because these end neurons are more easily activated, we can more efficiently and quickly build and strengthen the connections that are associated with performing the action successfully and with expertise. And what you see here is one of the devices that we use to do that is it's actually a commercially available device called developed by Halo Neuroscience. And I actually have an example of one of the devices right here. So you can buy these for about, I think, $500 to $700. It's my shameless plug for the company there. But let's talk a little bit more about what that's doing and what it actually does for gaming. So this device is really cool, and there's evidence that this brain stimulation can accelerate you becoming an expert or accelerate your performance improvements with training in a number of different skills. So whether that be in music and learning a musical instrument, or surgery, or sports like golf, which are kind of require like highly complex motor movements, or basketball, for example. There's been studies that have been done showing kind of evidence that this is a kind of a successful paradigm to improve performance. So where does it stand in esports? And I guess for many of you who are watching, hopefully many know what an esports is now, because it's really taken the world by storm. But an esport is really any video game that's played at kind of an organized, competitive, and or professional level. So you can see here, it's really massive in that you have teams that play professionally in front of thousands of people in big stadiums that would normally fill up for big concerts or big sporting events. And one of the most prominent esports in the last 20 years is the game Counter-Strike Global Offensive, or CSGO. It's a first-person shooter game, or an action video game type esport. And you usually play on teams of 5. And it's a really common esport, and there's a lot of professional teams and a lot of people that play worldwide. So the idea that you could maybe use this brain stimulation to improve the skills of this game, I think is really attractive. So in our lab, what we're doing is we're looking at some of the skills within the game Counter-Strike Global Offensive. And one of the skills that is deemed to be really important is obviously kind of this targeting skill. So you have to shoot and destroy kind of your enemies, right? So if you're facing a certain direction here, as indicated by the yellow dot, and your enemy is over here to the left, you'll often have to make kind of a quick kind of reactive movement to accurately acquire this target and then to shoot and destroy it, right? So you have to move over and then accurately eliminate that target. So that action in first-person shooter games is called flicking. And our research question was whether or not brain stimulation could accelerate performance improvement on the skill of flicking, which we've shown before to be a key skill for first-person shooter esports. Okay, so what did we do for the experiment? So what we did is, as you can see here, with CSGO, there are 18 different rankings that you can have in the game, from the lowest rank to the highest rank. So we gathered over 150 players across the different ranks of the games and separated them into 2 groups. The lower rank gamers, the low skill gamers, and the higher rank group, or the high skill gamers. And then we split those 2 groups into a brain stimulation group, so a group that did a certain number of days of training and had brain stimulation, or a placebo group where the same group did the exact same training protocol on the skill and we tracked their improvement, but they didn't receive any brain stimulation. And as I alluded to earlier, we used this Halo neuroscience device to kind of target the motor cortex and apply the brain stimulation there. So what did we hypothesize? So we hypothesized that brain stimulation would accelerate skill improvement both in our low skill gamer group and our high skill gamer group. So the brain stimulation versus the placebo would be different in both groups. So what did we find? So I kind of gave it away here, but you'll see brain stimulation for the win. But just to orient you real quick to the graphs, on the bottom of the graphs here, as you can see with my cursor